So morning, everyone. Just a bit of an intro just for the day, and then we'll kind of kick straight through. So thank you all for joining, first of all. Obviously, a little bit of a late change just from this being a face-to-face kind of in-person lecture to moving it online. Obviously, just training how people are working. This was a better fit at the moment for our kind of membership to have this kind of run live. What we do plan to do is kind of grab some feedback from you all, kind of post this to see what does work for you. We're really keen to keep these lectures, these kind of webinars coming to you, just keeping us kind of this insight from the industry and you know, a key part of what we do as a society. So we will be reaching out for a little bit of feedback on kind of what you'd like to see next. But what we have today is a great lineup. I'm going to just do a very brief intro for the day. The way we broke it down is obviously if you're on every single one of these, you'll see a brief intro for each one, just because people will drop in and out for the ones that are definitely relevant for them. So today at the spring lecture, we've got 5 speakers spread throughout the day kind of lined up. Obviously this morning we're going to hear from Mike, and I'll introduce the kind of abstract for each. We've then got a further lecture at 10 AM, another at 11, break then for lunch, and we'll resume kind of at 1 PM. You'll have a gap in the afternoon. We'll probably all want to go and catch up with emails and everything then, and then we'll be resuming for the final lecture of the day at 3 PM. All of the lectures will run for an hour. There'll probably be around 45 minutes presentation, and then we'll have some Q&A time in each. For the day, for your questions, what we'll do is once I've handed over, we'll hear from Mike shortly. I'll introduce the session properly. When it comes to questions throughout the day and recommendations, obviously set this up to full screen. You'll find a little option in the corner where you can change your view, and you can just put it into full screen view. So when Mike is sharing, you'll obviously get the true value from the slides and what he's there to present. From a questioning point of view, you've got 2 options for that. You can either pop them into the chat. Just make sure you select panelists, and that will make sure it comes through to me and Melissa. What we'll then do is we'll bank them up and we'll ask them on your behalf to Mike at the end. The other option is Q&A. So once again, you can pop your questions in there. And there goes my doorbell. Thank you. Put that in a sec. So yeah, you can also use the Q&A function. It's going to talk in the background. Good old ring. Apologies. Folks of live. That's fine. So yeah, you can also use the Q&A function. So post your questions in there. Ask away. We'll raise all of these at the end of the mic, and then obviously, hopefully get them all answered for you. Cool. So I'm going to just run into the intros now. So bear with me. I do need to read this off paper. Apologies, Mike, I haven't read this off by heart. We'll learn this off by heart, and all 5 of them. So just a brief intro for today. So first of all, we're going to hear from Mike Knott of Corning. So firstly, an intro to Mike. Mike is FTTH Market Development Manager with Corning Optical Communications, and he is considered to be an expert in this field with Corning and a specialization in FTTH markets, technology and applications. During 16 years in this role, he has gained extensive experience in FTTH network deployment and visited network operators in over 40 countries throughout the world. He is recognized as an authority in the industry in the field of optical connectivity and was appointed to the board of the FTTH Council in Europe in 2018. He is a member of the Institute of Mechanical Engineers and has held various technical and product line management positions within Corning. He has spent 3 years as a planning manager with what is now Virgin Media O2 during the initial Cat-V network build in the UK. Abstract or intro to the session. So we're surely going to hear from Mike on the FTTH rollout race, how UK AltNets can gain an advantage. With FTTH build in the UK at fever pitch, the winners will be those who can build the fastest and at the lowest cost. AltNets are increasingly dependent on Ofcom's initiative to allow AltNets access to Openreach's ducts and poles under the Physical Infrastructure Access Regulation. This presentation describes the challenges this presents and how these can be overcome by innovative optical connectivity solutions. Mike, over to you.
Okay, thanks very much. Let me share my screen first. Can you see that okay?
I can indeed.
Everything's showing up. That's good. Right. Okay. Well, I've got my fingers crossed now for any doorbell incidents or the cat suddenly starting a fight with the dog. Let's see what happens. And let's go. So thanks very much for the introduction. It's a pleasure and a privilege to be opening this SCTE spring lecture. I'm not going to go through my introduction. You've just done a great job of that. I'm going to jump straight into the slides. So who are Corning and what gives Corning the the credentials to come along and talk in this lecture? Corning, I suppose, can be best described as a specialist glass and materials company. You may not know, but it's actually 2022 is the United Nations International Year of Glass, and Corning are proud to be playing a prominent role in the celebrations for that year. In terms of fibre, well, Corning actually invented low-loss optical fibre. Corning is the most widely deployed brand of fibre in the world, and over the 40 years since fibre has been introduced, Corning have actually delivered 1 billion kilometres of fibre. And then in the next 4 years, we got to 1.5 billion. So you can see how much fibre is actually going into the ground. And to put that into context, how many times around the world is that? Well, it's 37,000 times around the world. So there's a lot of Corning fibre in the ground. Corning is, for an American company, it's a historical company. It's 171 years old. It's actually based in a small town in upstate New York called Corning. So Corning, the business, takes the name from the town. And Corning has about 50,000 employees worldwide and $14 billion of turnover. So, it's a big organization and a very proud track record of innovation. We go way back and we can claim some real inventions. We can't claim that we invented the light bulb, but we did invent the way to make the vacuum tubes, the vacuum envelope, so that the glass bulb could actually work. Similarly, Corning didn't invent the TV, but Corning invented a way to make the TV cathode ray tube. Corning didn't invent fiber optics, but they did invent a way to make fiber with an optical clarity and loss low enough to make it actually a practical realization in telecommunications networks. And one kind of highlight is when Neil Armstrong skillfully glided his lunar module onto the lunar surface in 1969. He was looking through a Corning window when he did that. Since then, there's been a number of innovations I'm not going to go through, but just looking at the breakdown of Corning's business, it's broken down into display technologies, which is the glass which is used in LCD TV screens. So the majority, or the biggest manufacturer of flat TV screens. Optical communications, which is the part I'm in. Environmental technologies, which is glass particulate filters and that kind of thing for engines. Specialty materials, so that's special types of glass, for example, the glass on phones and on tablets. And also in terms of life sciences, for example, the glass which vaccines are delivered in. So that's been a hot topic over the past couple of years, and Corning invented a new type of glass which meant it could be processed more quickly in the vaccine filling machines, which really helped the whole of the world. And Corning have delivered 5 billion doses of COVID vaccine in their vials. So if you think, people are actually interacting with Corning products, they're looking at Corning screens, they're touching Corning screens, and the information that they're getting is coming through Corning glass. So it really does touch people on a day-to-day basis. So in terms of optical connectivity, again, a track record of innovation. From 1970, when Corning actually provided the first low-loss fibre, innovations in cable, and particularly in later years as fibre has gone deeper and deeper into the network, and particularly into fibre to the home networks, it's really, the innovation is around the connectivity rather than the fibre. In other words, making ways of joining and connecting fibre in a cost-effective and reliable way that enable, fibre to the home networks to be built on a cost-effective basis. And Corning have actually delivered products to pass over 70 million homes in the world of fibre to the home, and that's worldwide in the US, Europe, Australia, throughout the whole of the world. So fibre to the home is definitely thriving in Europe. More than half of the homes in Europe were passed by fibre in 2020. And this graph here is from the Fibre to the Home Council. So I'm on the board of the council. I get involved in all these kind of things. And what the council do is they issue an annual report at their Fibre to the Home conference on the state of the nation, or the state of Europe, if you like. How many homes have been passed and which countries have done most of the homes passed. And this is kind of the top level graph, I guess. It goes right from 2012 to 2026. And it shows the cumulative number of homes passed in Europe, 39, which is all, includes all the East European states, and Europe, 27 plus UK. And what's interesting here is really the angle of that graph. The gradient of the graph represents how much business there is for vendors and how many homes have been passed per year. And you can see that we're really kind of in the peak period between sort of 2020, 2023 is the steepest gradient. If you go back to sort of 2028, it didn't really show so much on this graph, but now the number of homes passed per year is actually double what it was about 4 years ago. So we're really in the peak of the fibre to the home build right at this time in Europe. If we look at the UK, well, fibre to the home is definitely thriving in the UK. The UK were fairly slow to catch up compared to other countries, but now things are really happening. Openreach are planning to pass 25 million homes by 2025. They're building 50,000 homes per week at the moment, which is a pretty impressive build rate. And part of the reason they're doing that is in response to the independent operators, the AltNets. They're estimated to spend about 11 billion pounds to the end of 2025 on alternative fibre to the home networks. So, the UK is definitely a positive investment environment for telecom infrastructure funds. And when these operators do build networks, they are full fibre networks. It's really the undisputed preferred technology. AltNets cover all network sectors from dense urban to rural. So if you think about GigaClear working in the very rural areas, you've got Hyperoptic who focus on, high density MDUs, particularly in city centres, and let's say, the biggest AltNet, I guess, City Fibre, who do pretty much everything in between. And so really there's a race to establish a footprint, and that brings a focus on the speed of deployment. All the UK operators are building at scale in all network sectors. It really is a very, very vibrant business at the moment. So in terms of UK progress, or UK AltNet situation, this is a report which is created by INCA. INCA is the Independent Networks Cooperative Association, a trade body for the AltNets, basically. And you can see that the number of they issue an annual report by the analyst point topic, and you can see that in 2029 there were about 1.2 million homes passed by AltNets. That pretty much doubled in a year at 2020. 2021 it jumped to 6.6, and if everybody does what they've said they're going to do, there's going to be 29.9 million homes passed just by the AltNets. So, in 2025, so, that's a pretty significant build rate. And as you can see from the graph on the right, there's, that build is pretty much all over the country and focused in the centres of population. So what are the challenges for AltNets? Well, these challenges are not the ones I've thought of and put on a slide. These challenges are part of that INCA report I mentioned. Within that report, there's the AltNets themselves state, what their challenges are, and these are the top 4 challenges. So, firstly, overbuild. Second, wayleys, or building owners' permissions. Third, planning and streetworks, and fourth, access to skilled labour. So, what I want to talk about here is really how we can solve all 4 of those problems with optical connectivity solutions. If we look at a simple fibres of the home network, we have a central office or a point of presence, a head end, or whatever you want to call it. Normally, underground duct goes out from that that central office. We might have cabinets with optical connectivity equipment, but really the business end, I suppose, of a fibres of the home network, where most of a big proportion of the cost is focused, is at the end. In other words, at the terminals and the drops. And so, the terminals and the drops really have a major influence on, the build process. And that's what I want to kind of focus and talk about here. There are 3 main ways of doing this. The spliced, non-hardened connectorized drops and hardened connectorized drops. So with spliced, that's kind of similar to a copper drop or a coax drop, I suppose. You have a bulk of cable, a bulk reel of cable, and you just join that cable at either end. But of course, fibre is a bit harder to join than copper, so you're normally fusion splicing that fibre at the terminal end and at the customer end. You have non-hardened connectorized drops, so that's using standard fibre optic connectors, LC or LC connectors, inside closures or terminals. And you have hardened connectorized drops where you have, a hardened connector which is just connected to a non-enterable terminal like this you can see on the right. So what are the differences? I'm just looking at the sort of differences between non-hardened and hardened solutions here. Both are very, very widely used in FTTH networks. So with the non-hardened, well, the drop cables, they're using sort of standard SC or LC pigtails or terminated or possibly field terminated connectors. And obviously, every time you want to connect a customer, you have to open that closure. And then you have to seal the cable at the cable entry point of that closure as well. So you're getting involved in cable sealing and grommets and all this kind of thing. With the hardened, what you have is, the drop cables use this, hardened connectors. The terminals are often normally pre-stubbed, and what that means, that's a completely sealed unit. There's no work to be done on the terminals at the homes pass stage. You just mount the terminal and go, and there's no access to the installer for to the internal fibres. And that really gives a number of reliability benefits, which have been borne out with, the many tens of millions of homes which have been passed with these kinds of solutions around the world. What we have is a physical demarcation of the homes passed and the homes connected operations, different people doing the different operations, and the customer connection installers, they're often paid by the install. They're not concerned about the network reliability. They just want to make their connection and go to the next one. Whereas the network build people are more concerned about the long-term reliability of the network. So if we can keep those installers away from the fibre, that does give long-term reliability benefits. There's no possibility for the installers to disturb previously connected customers. I mentioned skilled labour. I also mentioned about the Fibres of the Home conference. There was a session in the last conference that was also an online conference back in September 2021. And that session was focused on the UK Fibres of the Home rollout. And there was one of these online polls at the time. And the online poll was what are the most important challenges for the rollout. And so this is real data that came, in real time. And you can see here, the biggest problem was access to skilled labour. So this splicing process that I mentioned earlier. So that's really borne out by real figures, you know, that from a live event. So if we talk about that skilled labour constraint, well, if you're going to build a fibre to the home network, there is going to need to be splicing. You can't get away from that, but we need to reduce that amount of splicing and sort of focus it in as few places as possible, because you have this, you know, kind of overhead every time you do a splice. You have to set up the whole splicing process, etc., etc. And that availability of skilled resource is definitely a problem. It's inhibiting the scalability of the build process. And, you know, for our example, there are events, you know, Inca are holding events specifically about this skilled labour shortage. That splicing needs to be focused where it's needed, not dispersed around the customer connection workforce. And so the lowest requirement for spliced labour is really using these hardened connectorized solutions, and particularly, you know, these stubbed terminals, where the process to install that terminal and to actually pass the premises is literally to fix it to the pole. Then you route all the stub cables back to a consolidation point and then do all the splicing in one go in one place. So you can see there's a big reduction in skilled labour with this kind of solution. I'm going to talk a bit about Openreach here and use it as a sort of testimony for this sort of solution. You know, Openreach are building, you know, as I said, about 3 million homes passed per year, and you know, they've done a lot of due diligence to, you know, to analyse the best way of doing that, and they did start off with blown fibre and fusion splicing, and found out that they couldn't get the operational efficiency that they needed. They worked, you know, to find a new way. They looked at, you know, the pre-connectorized solutions using OptiTap hardened connectorized products, and now that's what they're using, you know, for the whole of their network build. In their annual report of 2017, which was just after they kind of started the build, they included it as their, you know, as part of their sort of their technical innovation focus, if you like, in the annual report. And this is what they said: you know, connectorized fibre, we've developed a plug and play method of connecting properties to our fibre to the home network. We estimate that connectorized fibre and changes to our build process have helped us halve the cost of deploying fibre to the premise. So, I mean, you couldn't really get a better testimony for the technology than that. Now I want to talk about physical infrastructure access, PIA. So PIA is one of the key OFCOM initiatives to enable infrastructure competition. And PIA is the process where any alternative operator are allowed to place their cables and equipment on Openreach infrastructure, so in their ducts, chambers and poles. So Openreach OFCOM recognise that, you know, the cost of digging the holes in the ground is a huge proportion of the cost of a fibre to the home network, sort of 70 to 80% potentially. And to enable competition and to, you know, to release the significant market power that Openreach have with this asset, they open up the asset to alternative operators. Of course, AltNets have to pay a rental fee to Openreach. That pricing is controlled by OFCOM. It's all based on Openreach's costs. And PIA has actually had, you know, been around for quite a while. It's been reinvented as duct and pole access and PIA. And it did actually have a very, very slow take-up initially. You know, it was a complex process and AltNets didn't really see it as a viable solution. That has definitely changed. PIA is definitely taking off. You know, AltNets are deploying infrastructure at scale using PIA, you know. And there's a report from OFCOM, it's called the Openreach Monitoring Report, where they actually report, you know, on a number of aspects of Openreach's structural separation. And there are 98 operators actually deploying on Openreach infrastructure using PIA. I didn't even know there were 98 operators, never mind using PIA. So it shows you how well deployed it is. Every time PIA happens, the AltNet has to give a notice of intent order So letting Openreach know that the operator wants to use their infrastructure. There were notice of intent orders on 300,000 poles in June 21 and 496,000 poles by February 22. So you can see there's a huge rate of increase, and according to my calculations, about 10% of Openreach poles now have notice of intent PIA orders on them. That rate of growth is likely to increase as the AltNets increase their build. And there's a complex network adjustment process for cases where infrastructure is congested. That network adjustment process is all within the OFCOM regulation, and the prices are set within that regulation as well. What that means is that there's a fight for space on poles and in chambers, and that fight is definitely intensifying. So where do hardened connectors fit into this PIA deployment story? As I say, the incumbent operator has done extensive technical and financial evaluation to find the most reliable solution. They did select these hardened OptiTap drops and terminals. They call them CBTs, Connectorized Block Terminal. We've worked closely with UK operators, Openreach and AltNets to sort of tailor the portfolio to meet the specifics of the UK environment. And the benefits of using those products for PIA, well, they're pretty clear, I guess. Openreach have their own requirements, which they set on any operator using PIA. There are particular specifications of the products, not really related to the optical performance, but definitely related to the mechanical performance. And they are specific to the industry, specific to Openreach, not common within the industry. So, there's an aerial spec CP08. Clearly, our products and these type of products have met that specification. So, it's taken as a given that any AltNet will be given permission if they're using these products. They're proven to be the most cost-effective solution. And of course, there's a big turnover in contractors at the moment as they're moving from company to company. And if they're familiar with the processes and products of one company compared to the other, there's definitely benefits there to be had in transfer of the installation labor. Now, I talked about where we are. Now I want to talk about where we're going, and I want to talk about this problem of congestion in the network. Where we're going is, the old products, the OptiTap products, technology doesn't stand still. And what we have now is a new range of terminals and drops, which are smaller and more compact and better looking, if you like, than the old products. We call it Evolve push lock technology, and it consists of a miniaturized connector and a smaller aesthetically designed terminal. And this is a terminal, and just to give you an idea here, that's my phone, which isn't showing up in a strange way. That's my iPhone. That's the terminal, and you can see, the size difference compared to the old terminal is pretty significant. This is a 4-port terminal, which, sometimes if I'm doing this presentation on stage, I slip this into my jacket pocket. You can see the old terminal here. This is the 4-port terminal, and this is the new 4-port terminal. So the connector is a new, revised connector. It's about half the size of the OptiTap, the old connector. It has what we call a stick and click connection. So to make that connection, you push the connector into the port and you hear this audible click. There's no bayonets, there's no screw caps or anything like that. The terminals are 4, 8, and 12 and 16 port configurations. They obviously have this reduced footprint. They're aesthetically designed, and to meet any network, whether it's point-to-point, centralized split or distributed split, they're available in stubs, stubless and splitter versions. This is kind of a showing the different port count terminals, and here we have, the new 4-port compared to the old 4-port, the new 8-port compared to the old 8-port. So the difference is really around the port size and the location. All the ports are across the bottom of the terminal. All the input cables, the stub cable is also at the bottom, so everything is into the bottom of the terminal. We have these disengage buttons to release the connector. So you just press the button and release the connector, and when you press the button, the connector pops out just by a few millimeters, but it stays in position, and then you can just pull the connector out, and then you can just push it back in. So it's a single-handed operation, which is going to be important if you're up a ladder on a facade of a building or up a pole. You can see here I'm just pulling out this is a dust cap I pulled out there, and then to push it back in, you can hear the click engagement there. The aesthetics are fairly clear, compared to the old product. It's a much thinner terminal, and we have this planar cable routing where everything is coming out flat to the wall and all in the same direction. So you don't get this congestion of cables as the drop cables are connected. So where do they fit into cable TV networks? Well, these terminals are going to fit where other hardened or even non-hardened connectorized terminals won't fit. So in the Virgin Media O2, the old 9X network, I'm kind of familiar with this. I used to work for this part of the company, and you can see you've got these handholds which were designed to pull in drop cable. They weren't designed to take any kind of HFC hardware or fiber to the home hardware. But now that hardware has shrunk so much, you can fit one of these terminals very easily into the smallest kind of handhold here. You can see one just placed in amongst all the existing coax drop cables. So there are a number of benefits there. There's no upgrade to the civils network. Obviously there's Project Mustang, where the HFC network within VMO2 is being upgraded to fiber. It means there's shorter drops. You're moving the terminal closer to the customer, so reducing drop congestion in the network. And of course, that's the amount that you can cut down on that civils upgrade is a big influence on the reduction of the cost. Going back to PIA deployments, the infrastructure is congested with that legacy copper and fiber infrastructure. The terminals, the benefits of these smaller terminals are in terms of space. So, the terminals can be installed where OptiTap terminals won't physically fit. They're easy to install. There's fewer of these network adjustments which are going to be needed, faster rollout and reduced complexity. And of course the aesthetics. So where terminals are placed on on their facades, then the way leaves are going to be easier for these more attractive terminals. Now I'm just going to look at the application, in turn, the different applications for AltNets using PIA. If you look at congested poles, just look up in the sky and you can see what's going on there. Pole congestion is a challenge. So these aren't specially selected poles. These are pictures of poles that I've took as I'm going about my daily business, walking around the streets of the UK. So yes, okay, I am a bit different. I always look up there and see what's going on. My wife's exasperated as I stop the car and take a picture of a pole. But these are the kind of things that you see. So what's happening is there's that congestion is increasing, and there's a pinch point here where Openreach are building like crazy. AltNets are increasing their PA deployment, but Openreach are not allowed to take down their their copper hardware. So everything has to exist at the same time, and that's where we're getting this real pole congestion problem. Clearly, a terminal like this will fit much more easily on the pole. What happens if the pole's full? Well, I mentioned we have this network adjustment process, and the cost is £543 per pole. So, okay, it might be a fairly rare occasion that a pole has to be completely built, a completely new pole. But when they are built, there's a very significant cost. Also, there are some metal hollow poles in Openreach's network, and the Evolve terminals will fit inside those metal poles where the old CBT terminals won't. In terms of underground congestion, that's also a growing problem. The terminals are normally mounted in Openreach's network on these MOBRA mounting bracket folding arms. And these much smaller evolved terminals can be mounted on a simple compact bracket, which I'll show in a couple of slides. Again, you know, it might not be a hugely common case that a new terminal, new chambers are needed, but when they are, the network adjustment cost is £817 per chamber. For facade deployment, you know, it's really the size and the appearance in the which are the most appropriate. And well, within Openreach's network, you know, there is actually a surprising amount of facade deployment. You know, along high streets and commercial shop frontages, there are historic buildings and you know, externally cabled MDUs. And it's about 10% of Openreach's network, which does actually use facade terminals. And already there have been many cases where evolved terminals have been approved by building owners where OptiTap wasn't. And that's even on historic buildings in conservation areas and this kind of thing. What's the alternative? Well, you know, if you can't use the facade, you know, you need to build a new chamber potentially at, again, £817 per chamber. As you look into the sky, you'll see all these shiny brackets where more than one terminal is mounted on the pole in order to conserve space. Those brackets cost money. And, you know, there's a potential elimination of those multi-terminal brackets. For underground, I mentioned we have this MOBRA swinging arm. Openreach have this no drill frame, which is mounted inside the chamber, which is, you know, it's kind of an expansion device on here, which means you don't have to drill it, drill the walls of the chamber. And we have this very simple metal bracket, which fixes onto their existing no drill frame, and you just hang the terminal from there. So it's much simpler, much less space, much cheaper. And also we have 16-port terminals. So, you know, often 2 8s are mounted where 16 ports are needed. Clearly, one 16-port is going to save space compared to 2 8s, but also in PIA, you pay per meter of cable as well, both in the duct and also, you know, the cable routed along the pole. So if you're routing one single stub cable, that's much lower cost than 2 stub cables. So there's advantages there for PIA operators. And finally, new build. So, you know, normally, you know, the Openreach specification for new build, they build very generous chambers. You know, you know, can be brick built or can be prefabricated. But clearly, the hole that these terminals need to go into the ground are much smaller, and these kind of very small sort of plant pot type underground chambers, you know, are suitable for these kind of terminals. So there's clearly some pretty significant savings to be made. So I talked about these AltNet challenges. Let's come back to the beginning. I said, well, we can address all 4 of those challenges. So in terms of overbuild, well, I mentioned about, you know, the pre-terminated terminals, reducing spliced labor. That means that the whole network can be built faster. And so, you know, you get in there first, which gives you that first mover advantage, which is so crucial with overbuild. Way leaves, I think that's pretty self-evident. You know, there are proven cases where, you know, these terminals can be, you know, have been mounted where the old CBTs weren't. Planning and street works, well, I think that's really around, you know, fewer civils upgrades. You know, that's going to reduce the amount of civils infrastructure, and therefore, you know, reduce the problem with planning and street works. And finally, you know, with any hardened connectorized solution, we've got this access to skilled labor, reduced splicing, and so that alleviates that problem as well. So in conclusion, you know, the key to success for AltNets is really speed and scalability of the build process. Same applies for VMO2, you know, whether you consider them an AltNet or not. You know, these OptiTap, you know, CBTs have proven to be, you know, to be useful and effective, and you know, and sort of lowest cost solution for fibre to the home builds in the UK. But, you know, the new generation evolved terminals definitely give you a, you know, a head start, you know, a push forward in the race to deploy, particularly for AltNet PIA deployments. So if you want to follow that up, our local guy is Nick Food, who addresses the AltNet market in the UK. Here is details, and thank you very much for your time. I hope that was interesting and useful, and obviously I'm open to any questions you might have.
Thanks, Mike. And very interesting. Definitely looking ahead at stuff like Mustang and future. I'm a VMO2 person, so yeah, absolutely. There's a couple of questions that have come in via chat. I think you've touched on probably all of them in some way, but I will re-ask them just in case there's anything more you want to add. But likewise for everyone else that's kind of listening, if there's any questions that you've got post now that you've seen everything, by all means drop them in the chat. If you want to raise them yourselves, by all means we can drop you off mute and you can ask that and speak it through. Just raise your hand and we can come around for you. But I'll run through the ones that have already been submitted, and then obviously if you've got any further thoughts, Mike, by all means. If not, we'll kind of run through them. So first question, you mentioned that there are cases where the new evolved terminals are allowed on buildings facades, and you give a few examples of that, where old ones were rejected. The ask was for examples of that. Now we've seen a few from the images and point of view, so I just wondered if you wanted to revisit that, or if there's any more specific cases that you'd seen.
Well, I'm going to use a case which is in the public domain, which is Openreach. Openreach used the city of Salisbury as one of their trials to actually, I mentioned about removing the copper network. So Salisbury was the first town that Openreach chose to actually completely replace their copper network with fibre. And Salisbury, as we know, has a historic town centre, and there's some facade deployment on some listed buildings. And when Openreach turned up with their CBTs, basically the council said, there's no way you're putting those on these listed buildings. But the choice for, because they were taking out the fibre, that was part of the trial, there was no alternative. Either those buildings lose out and they don't have any connectivity, or we find another way. We approached them with the new terminals, which are just being introduced at the time. And the conservation officers said, oh, actually, they're not bad. Those are pretty discreet. They look much better, and they were accepted. So that's a great case of a real problem that was solved just by and it's the judgment of a conservation officer who makes that decision. And yes, those were installed and everything was it was a successful conclusion.
Cool. Interesting example. Thank you. Next question. So why do you think physical infrastructure access is now being used so widely? As in, yeah, well, it was a difficult process, and I'm not directly involved in PIA. I know there's quite a lot of accreditation and this kind of a lot of process that needs to be gone through. I think that the main problem was the process. So obviously there's sharing of maps and GIS and many interfaces and that kind of thing, and the time taken to actually go from, okay, I want to build here, to actually getting the access and everything else was a problem. And also there's been a lot of iterations from Ofcom in terms of what the form of the regulations, and Ofcom have significantly reduced the price. In the wholesale fixed telecom market review last year, was it? I think, yeah. The cost of the rental charge for aerial was significantly reduced. So the process being improved, the rental charges being improved, being reduced. The business case has come together. AltNets have started using it and found that the process is actually viable now. And in fact, I've seen sort of senior people from AltNets at conferences stand up and say, well, it has been a problem, but now it is a viable business solution for us. It is working. It can be improved, but it is working. So that, I think those reasons really. Awesome, thank you. A few more, just going to keep running through. You handle them very well. So in your thoughts, your eyes, where is the UK in its FTTH build compared to other countries across Europe?
Well, I mentioned that more than half of Europe is now, half of all homes in Europe are now fibered, basically. UK is behind. It's been a slow start. Fibre to the home has been around, the first, large-scale builds were 2004, in fact, based in the US. But certainly the pioneers in Europe were sort of the Scandinavian countries, and the first major rollouts really, I suppose, after that were sort of Spain and Portugal. A lot of the Eastern European countries are quite a way ahead, but Central Europe and sort of the UK, Germany, Austria, Switzerland are behind, and the reason is a lot of VDSL was installed, and they got more and more out of the copper. So now what's happening is UK and Germany have got I guess the business case for fibre has improved, and now they're moving forward, and that's where a lot of the business will be. So yes, the UK are behind the rest of Europe, but looking at the build rate at the moment, they're catching up very, very quickly. So yeah, it's like I say, it's a very positive sort of business environment, I suppose, for fibre. But because of the amount of HFC that VMO2 have got in the ground, and also the the quality of the copper network, I guess from BT has enabled VDSL to do a lot. But now VMO2 have got Mustang, and Openreach are building, and all the AltNets are doing their bit as well.
Awesome, thank you. So you referenced one of the problems that this solution solves is the need for skilled labour, but there is still an element of skilled labour required. So where do you think AltNets operators will get that skilled labour from if it is a shortage? Well, we know it's a shortage.
Well, there's a lot of initiatives to bring that labour in. I know that a lot of the sort of training schools that are being set up, Openreach, again, coming back to them, they're investing a lot. They're taking on thousands and thousands of installers for sure. I think the key thing is to reduce the amount of skilled labour that is needed is one thing. But I know there's been a focus on the armed forces and this kind of thing, bringing people in from that kind of area. I'm not going to get into the sort of Brexit discussion, but for sure that's not helped. I think that the way to go is really to try and reduce the amount of skilled labour rather than bring in a lot more. So. But it is still, an obstacle for installers, because it is a very, very transferable skill. Once you've been trained on splicing, there's only a certain number of products around, and a lot of the operators are using the same products, and so it's very easy for a splicer to say, okay, well, I'm being paid a daily rate here with that company, and I can get it only takes a small amount for them to transfer across. So it's really the skilled splicers are in the driving seat at the moment, for sure.
Yeah, thank you. Right, fun question. So by all means, anyone else, if you've got anything, get them in quick. So one that's just come in on the Q&A, we just answer live. So earlier in the presentation, you referenced that your products were proven to be the cheapest. Just a little bit of further context. So what was the basis of this proof, e.g. how many alternative products were compared and when? So just a further bit of insight into that.
Well, when I said they were the cheapest, that was in the context of the Openreach decision to select the OptiTap, the CBTs, etc. They were previously fusion splicing. And they did a lot of work in terms of evaluation. If they're investing, is it 10 billion pounds in their network, a big proportion of that is actually in the terminals and drops. You might, if you look on an architecture diagram, it's only the last little bit at the end, but when it's multiplied by the number of that, of that short length, then it's a big, it's a big thing. It's a big part of the cost. And at the moment, there are thousands of people as we speak out installing drop cables. And so, you know, and it wasn't just, you know, the cost of the materials, the cost of the products, obviously. It's the cost of the the installation and the ongoing cost of maintenance and repair and all this kind of thing, you know. So it's on that basis that you know, that decision was made.
No, thank you, and well handled. Cool, that's all for questions for now. So I suppose on behalf of all of us, thank you very much. Really insightful, really interesting.